where f of x will be considered as y. So instead of writing f of x in any expression or equation, they are going to write y. For example, in this first case, this is the first, it was like this, it is 5 into f plus x into f of x to the power 3 plus x square f of x plus y to the power 4 means f of x to the power 4 equals to 4. So instead of writing f of x, they have replaced your f of x by y, right? So whenever they are asking you to find dy by dx, that means you have to find f dash of x, that is derivative of x, right? So all the operations that you are doing for f of x, all you have to perform the same operation y, keeping in mind y is only an f of x or substitution of f. This is in a crude language I am telling you. Okay. So if f of x to the power n, what we are doing? N f of x to the power n minus 1 into derivative of f of x we are doing. In the same way, if y to the power n is there, here I have replaced f of x by y to the power n, y, n will be there. So y to the power n derivative will be n, y to the power n minus 1, because we are considering y as f of x, derivative of your f of x, that is y, right? So y to the power n derivative will look like n y to the power n minus 1 dy by dx. The same process you have to apply for every question now onwards, if it is in your implicit function form. Okay. Now let's take this first question. Here in first question, if you observe, let's say this question. I'll write it again, x to the power 5 plus x y cube plus x square y plus y to the power 4 equals to 4. Now if you want to differentiate it with respect to x, what will be the steps? X to the power 5 derivative will be 5x to the power 4. As simple as that. Here x is one function and y is also one function. So it will come in under u into v formula, right? U into v. If u into v is there, form is there, what we are doing? We are taking the first common, finding the derivative of the second expression plus second expression common and finding the derivative of first expression. So similarly we have to follow this. Okay. Again plus, here again u into v, first common derivative of second common derivative of first expression, right? Plus again this is now e, this is y to the power 4, y to the power 4 derivative we have to find. It will be 4 y to the power 4 minus 1 into derivative of y, because we are considering y as f of x, equals to derivative of your 4 will be 0, right? Because it is constant. So what I will get? 5x to the power 4 plus this x common, derivative of y cube, it will be 3y square dy by dx, right? Plus y cube, derivative of x, it is 1, plus x square common, derivative of y, it will be dy by dx, right? Plus y, it will be derivative of x square will be 2x, so I am writing it as 2xy. I have just written derivative of x square first and then y, plus here 4y, 4 minus 1, 3, 4y cube, then dy by dx. Yes. I think everyone got this, right? Yes or no? Now, what I will get? Just take all the terms of dy by dx containing dy by dx to the left hand side, right? Make it to the left hand side and shift all the other terms who are not involved in dy by dx to the right hand side. So what I will shift or what I will take to the left hand side. So this will be same. So it will be 3xy square dy by dx plus next one will be my x square dy by dx plus 4y cube dy by dx will remain on the left hand side and the other terms will go to the right hand side. So this will be on the right hand side, what I will get, minus 5 to 4. Again this minus y cube. Again this minus 2xy. Right? Now on the left hand side I will take my dy by dx common. So if I take dy by dx common, what I will get, 3xy square plus x square plus 4y cube, right, equals to, here if I take minus common, what I will get, minus in bracket 5x to the power 4 plus y cube plus 2xy, right. Now I will shift this whole term to the right hand side. What I will get, dy by dx is equals to my, this will be my same numerator, 5x to the power 4 plus y cube plus 2xy, right, and this will be in my denominator. So what I will get, 3x y square plus x square plus 4y cube, right. So this is my answer. In this way I got my dy by dx. They were asking you dy by dx, right? Find dy by dx, right? Now I believe everyone got this, how to find dy by dx if the given expression or equation in parametric form. Just deal your y term as a function. X will be as of this a function and all the other terms irrespective of x and y, all the terms will be considered as constant. Okay, everyone got this? Now the second question. Here in second question. Just differentiate it with respect to x. Now y cube derivative will be 3, I'm writing here, y square dy by dx, right, plus cos of function. So what is the derivative of cos of function? It is minus sine of function into derivative of function, right, equals to, what is the derivative of x square? It is 2x minus sine of function. What is the derivative? Cos of function and then derivative of function, right. Now this will be my as of as 3y square dy by dx plus into minus sine of xy. Again this is in xy is in u into v form because x is a function of x, y is also function of x. So we will write in bracket. We will take first expression common derivative of second expression plus second expression common derivative of first expression, right. Here 2x minus cos of x plus y. Again this will be in your bracket, right. Derivative of x 1, derivative of y dy by dx. Okay. Always keep in bracket. Now again, three y square dy by dx. Just simplify all the terms. Multiply this term to the bracket. So what I will get, minus x sine of xy into dy by dx plus this y will be there, derivative of x will be 1. So it will be only y into minus. So it will be minus sine of xy y into, right? It will be y into sine xy divided by, sorry, this only y minus y sine xy, okay, equal to 2x. Now multiply this to the bracket, minus cos of x plus y minus cos of x plus y dy by dx. Now take all the dy by dx term to the left hand side and other terms to the right hand side. So what I will get, all the dy by dx to the left hand side. Instead of writing dy by dx, you can also write dy by dx as, just remember this, you can also write dy by dx as y1 or y dash. So to reduce the writing work, now onwards I will write dy by dx as y1. Okay. So what I will get, this will be my y1. Okay. Minus x sine of xy. This dy by dx will be my again y1. Okay. This will be to the right hand side. So what I will get, plus cos of x plus y dy by dx. I am writing dy by dx as y1, right? Equals to all the other terms which are not involving dy by dx should be at the right. So what I will get, this 2x. This will be minus cos of x plus y. And this term will be to the right hand side. So it will be y sine of x plus y. Okay. So it will be sine of x plus y. I believe everyone got this. Okay. Now in this expression, just take your y, one common. So what you will get, 3y square minus x sine of xy plus cos of x plus y in bracket your y1 equals, what you will get. Here you can't do any adjustment, so it will be as it is. 2x minus cos of x plus y plus sine of y into sine of x plus y, right? Okay. Now take all this term to the right hand side. What I will get, y1, that is my dy by dx. What I will get, 2x minus cos of x plus y plus y sine of x plus y divided by this term, whole term. So what I will get in denominator, 3y square minus x sine of xy x plus y, sorry, xy. It is xy, right? xy plus cos of x plus y. So this is your final answer. dy by dx. Always make bracket to your last answer. Okay. So it will be very easy to check for the orator last answer. So dy by dx are. So this type of question will be little bit lengthy, but it is very simple. And if you observe, you just have to concentrate on your basic. You should follow the steps to solve differentiation that we have seen previously. Okay. Now this third will be homework for you. Just treat your e to the power f of x here. So e to the power f of xy, derivative of xy you have to solve. This also, log of f of x, treat it as log of f of x. 1 upon f of x, derivative of f of x. Just solve this. So it will be homework. Right. Now the second type of question. Here you can see x to the power m, y to the power n equals to x plus y to the power n plus n is there. We have to prove that dy by dx is equals to y by x. That means we have to find dy by dx. So by using any means, I have to eliminate this x to the power. So that is, this powers have to eliminate m and n by any means. Here I can see it will be very easy if I take log, because indices are there. Okay, exponents are there. Okay, so here for this given, I will by taking log on both sides. Okay. So what it will be? So I will get log of x to the power n, y to the power n equals to log of x plus y bracket to the power n plus n. Right? Now here this is in multiplication. So log of a into the formula we are going to use log of a plus log of b formula. Here also, here log of a to the power b formula. This will come to my at the front, so I will get n plus n log of x plus y. Okay. Next. Now, this solve by applying the formulas, and after that, if the function or the given expression in proper simplified form, then take the derivative. This m will be at the front. This n will be at the front. So what I will get? M log of x plus n log of y equals to m plus n log of x plus y. Now this is in simplified form as compared to the previous one. After this, you can't further apply any formulas of log. Now onwards, take the derivative. Differentiate with respect to x. So what I will get? M will be common. Derivative of log x, it is 1 by x plus n common. Derivative of log of function, 1 by function, derivative of function. M plus n common. Derivative of log of function, 1 upon function, derivative of your function. Right? Same method we are following here also. Again now, what I will get? M into x by y. M into 1 by x. So it will be n by x plus this will be n by y into derivative of y dy by dx equals to m plus n. This will be in the denominator into derivative of x 1 derivative of y dy by dx. Okay. For this, now take your dy by dx term, all the terms to the left hand side and other terms to the right hand side. What I will get? I will write this n by y dy by dx. Now this will be my positive. If I take it to the left hand side, what I will get? Negative. It will be minus m plus n upon x plus y into dy by dx. Right? Equals to m plus n upon x plus y minus, this will be to the right hand side. What I will get? M upon x. Now onwards, take dy by dx common. Dy by dx common. What I will get? N upon y minus m plus n upon x plus y equals to, and now follow the addition method. Multiply by x. What I will get? M into x plus n into x minus again m into x minus m into y upon x in bracket x plus y. This cross multiplication I did this. Okay. Next. Here also this cross multiply. Dy by dx in bracket x into n, that is nx plus ny minus into y, this right. So it will be minus my minus ny upon y into x plus y. Right? Here also. Now here you can check this mx will be cancelled. Right? So what I will get? Nx minus my upon x in bracket x plus y. Similarly here also this ny will get cancelled. What I will get? And in denominator also dx x plus y will be get cancelled. What I will get? Dy by dx in bracket nx minus my upon y equals to nx minus my upon x. Here you can observe this will also get cancelled, nx and y. So what I will get? Dy by dx in bracket 1 upon y equals to 1 upon x. Now multiply this y to the right hand side. What I will get? Dy by dx equals to y by x. So this is our proof. This was our source. Right? This is our proof. This is the final answer. That is, we have proved. Then right here, hence proved. Right? I believe everyone got this. Now in this type of question again, sign of this expression px to the power m minus q y to the power m upon px to the power m plus qx to the power y to the power m equals to r. So in this type of function, they are asking you to show dy by dx equals to y by x. So here what we will do, here if I solve by regular method, that is sign of the function, it will be really lengthy and it will be very complex to find dy by dx, right? So what I will do, I will change or I will eliminate this sign. So how to, I am not exactly eliminating, I am just sending it to the right hand side. What I will get, as here r is constant. What I said, x and y should be considered as a function of x because you are taking derivative with respect to x. Here also they have more specifically provided r is constant. So if I take this sign to the right hand side, what I will get, p x to the power m minus q y to the power n m upon px to the power m plus qy to the power m. Okay. So what I will get, sine inverse of r for this. Now after this step you should not take directly derivative. Some students start thinking, I will consider this as my y by x formula or u by v formula, right? U by v formula. So in left hand side, what I will follow, what you are thinking to follow, derivative of u by v formula, and this will be my 0. So at the end, what I will get, v dv u by dx minus u dv by dx upon v square equals to 0. This v square will be 0. Multiplied to this, I will get 0. U dv by dx du by v in bracket du by dx minus u dv by dx. Now we will solve, simplify it, take the dy by dx to the common and shift all the terms to the right hand side. Ultimately we will get dy by dx equals to y by x. That they are asking us to prove it. But this is wrong. Whenever you are multiplying your denominator to the 0, it is creating all your term to the 0. It is not possible because this is here y is a function of x. You can't directly multiply it to the 0 to the right hand side and make it to 0. So in such cases, what you are going to do, you are not directly performing this step because you can't eliminate this sign inverse. It should be there. So what I will do, I will put it as t. Temporarily I am going to put it as t. Okay. I will consider it as t non-inverse. So what I will get, p x to the power n minus q y to the power n. This will be to the my right hand side. What I will get, t into p x to the power n plus q y to the power n. Right? Now solve. P x to the power n minus q y to the power n equals to multiply by 2t p x to the power m plus t into q y to the power n. Now take your y terms to the left hand side and all the x terms to the right hand side. So what I will get, this will be to the left hand side, what I will get, minus tq y to the power n minus q y to the power n. This will be as it is, tp x to the power n minus this one to the right hand side, p x to the power n, right? Now you can take the minus common, or if you are not, solve as it is. Now here I will take my minus q common on this board term. Minus q common. What I will get? Here we have to eliminate this r. Okay, we'll see. Ty to the power n minus y to the power n. Here again p will be my common. 2x to the power m minus px to p is common. It is x to the power m. Okay. Now differentiate. Here this is m. This is m. You can also take the y to the power m also common. Right? We also take the y to the power n common here. X to the power m also we will take common. So on left hand side what I will have q y to the power m in bracket t minus 1. Right? Here p x to the power m common t minus 1. Now these are the terms equal. Now you can cancel out. You should cancel by eliminating it or cancelling it by the division. Proper division should be done. That is, same terms are there, then you are going to eliminate it. But you are not going to multiply it by to the 0 and make the 0 also. So, this type of adjustment you have to keep in mind. Okay, so what I will get? Minus q y to the power m equals to px to the power m. Right? Now you can change it to the left and right hand side. What I will get? Y to the power m upon x to the power m equals to p upon minus q. That is minus q by. Now if you take the derivative, you can take it to the 0. Now students will start asking, sir, if I take this derivative, I have to apply this u into v, right? U by v formula. That is denominator common derivative of numerator minus numerator common derivative of denominator upon denominator square. And this will be as this is constant, this is, the derivative will be 0. So why I have not applied this method previously, u upon that we have discussed? Because here r is a function of x, right? R is a function of x. That means sin inverse is also a function of x. You can't directly take it to the 0 after taking differentiation. That's why we have not applied u upon v formula here itself. On left hand side you are able to take u upon v formula. You can't take this 0 because r is the function of x. Here you can see r is sine of a function. So r is also a function, but they are saying on the right hand side r is constant. First I have to make r a constant and then I should eliminate it. Okay. After looking to the expression, r is looking like it is a function. Okay. Or here you can observe sine inverse of r is also function. You can't take sine inverse as r, they are giving you as a constant, but sine inverse of r is a function. You can consider it like, okay. So this you should keep in mind when you have to take the derivative of right hand side to make it 0 and when you don't have it. Okay. Now here this will be went to right hand side and it will be 0, right? Because here this is a perfect proper function. You can take it to the left or right hand side and make it to the 0 after multiplying to the 0. So what I will get? X to the power m, y to the power m will be m y to the power m minus 1 dy by dx minus y to the power m common derivative of x to the power m x to the power m minus 1, right? Equals to 0. Now this will be multiplied x to the power m y to the power m minus 1 dy by dx. I will take this term to the right hand side. What I will get? Equals to y to the power m into x to the power m minus 1. Here you can observe m will get cancelled, right? My dy by dx will be y to the power m to the power m minus 1 upon x to the power m and into y to the power n minus 1. Here power is same, so I can write y upon x to the power m, right? Here also power is same, that's why I can write y to the power n minus 1. Now here you can observe, take the reciprocal of this, I will get y by m. Just I need to change the sign, because we know if I take reciprocal of anything, I should change the sign of your index, right? Same I will apply here. So what will be minus m minus 1, right? Here the power is n. Now I have to add this, because now the base is same, 2x. Okay. Now y by x that is common. I have to add this. After adding, what I will get m plus minus m minus 1. What I will get? Y by x m plus minus into m minus into minus 1, it will be 1. This m will cancel. What I will get? Y by x bracket to the power 1. That means y by x. On right hand side, left hand side, what we have? dy by dx. So this is my answer. dy by dx equals to y by x. Hence proof. They were asking you to prove this, right? Simplify the baki. Here I will convert this my left hand side to cos inverse. Cos inverse of this, take the reciprocal, x cube minus y cube upon x cube plus y cube. Right. Here I am using the formula sec inverse of x is equals to cos inverse of 1 by x. Just take, we are taking the reciprocal of your input. Now same as previously, take this cos to the left hand side. What I will get? X cube plus y cube, minus 1. Minus y cube upon x cube plus y cube equals to cos of 2a, right? Now multiply this to the right hand side. Here also we are not taking u by v formula and taking the right hand side to 0 after taking derivative, right? So what I will get? X cube minus y cube equals to cos of 2a into x cube plus y cube. Just multiply it, take all the terms of y to the left hand side. You will get a y cube at the left and all the terms on the right. Now you have to take the derivative, find dy by dx and prove it to dy by dx equals to x square tan square a upon y square. So this will be homework. Okay. If you are facing the difficulty, we will solve it in next session. Okay. Now in this type of question, here your root is going to infinity, right? So what I can do, I know y is root of tan x plus root of tan x plus root of tan x plus going to the infinity. That means I can put this term, that is root of tan x plus root of tan x plus root of tan x up to infinity as y. You can put this as y. Or after taking the square root, I will put. First I will take the after taking out the square root, I can put. So first I have to eliminate this first square root. What? To eliminate the square root, I will take by taking square on both sides. Just take the square. What I will get? Y square equals to tan x plus, this will be same here, root of tan plus root of tan x plus root of tan x up to infinity, right? So this I can put as y, because it is y, right? So here just put it as y. So what I will get, y square equals to tan x plus y. Now take the derivative. What I will get, 2y dy by dx equals to derivative of tan x 6 square x plus delta y dy by dx. Take to the dy by dx to the left hand side, what I will get equals to 6 square x. Now this 2y minus 1 will be to the denominator. What I will get, dy by dx equals to 6 square x upon 2y minus 1. Okay. So this is my final answer.